Hi, today we are going to do a code review of a repository called Master Blaster by the user TwitchKid. Now, this is a project that's purpose is to rename your main branches. So, for example, if you want to rename your own master branch to something else, like the main branch, then you can use this tool to do it. But the most obvious thing when you look at the code and the README and whatnot is that there are lots of these kind of warnings. Warning, this is not guaranteed to work. And if we even look at the code, first thing that the author makes sure we see is that this comes without any warranty, so it's not promised to work. And even if we run the code, the first thing that prints out is the same thing, that this comes without any warranty and you're on your own if you use this. Let's be honest, if I would use something that potentially destroys my version control, I would make bloody sure that it works as it's supposed to work. So using something like this on a version control, which contains business critical software's source code, I would probably skip it. But I wonder that where this comes from, because as a developers, like we should be able to trust our code, right? So why is it that this author does not trust his code or her code at all? I think that it boils down to this. So this whole project is 1000 lines of procedural code. So this is all that you have in this project. So it's just lots and lots and lots of different for and if loops and not that many abstractions and 0 tests for this code. And if you skim through this code, which we are not going to do because it's 1000 lines long, you will see that this is really low-level code, and it's a procedural code. So it's really hard to test this kind of code because you don't have these kind of testable entities as you would have with, for example, object-oriented code. Or you don't have testable pure functions that you would have with functional code. But you just have a code file that starts from somewhere, then it does a bunch of stuff, and then it exits, right? The last thing is literally system.exit. So how could we reason about this code, right? It's 1000 lines long. You cannot simply, as a human being developer, you can't just read 1000 lines and then start reasoning about this. It doesn't work that way. 1000 lines is just too much code to reason about. So I think it's pretty clear now that why the author thinks like this. But how could we fix this? So I think I would describe this code as written from bottom up, right? And what I mean by that is that you are doing lots and lots of low-level stuff here, but you only have 1 or 2 levels of abstraction on top of that. And even those abstractions are like, they are just regular function calls. So what I would do instead, as a thought experiment, we could describe this functionality from looking from the top down. And let me show you what that means. So this is Replit, and this is Python REPL, which means that I have a Python file here on the left, and it runs in my browser, and anything that its outputs will become visible on the right. So for example, I can do something like print hello, and then it should appear on the right. Okay. So if we would start to describe our software here, so a project that takes one repository, let's start with just one, and then it changes its branch's name. Right, so first of all, we probably need to know the new branch's name. So for simplicity's sake, I will abuse the dynamic nature of the Python, and let's just do something like utils is an empty object, dictionary. We're now in Python. Sorry, my Python might be a bit rusty. I haven't done this in like 5 years or so. So forgive me if you see anything weird going on here. But yeah, so then when we have this empty utils dictionary, we can start writing kind of pseudocode with Python. And then like let's just try to describe what our program does in code. And then let's worry about the implementation later on, right? So let's say that branch name or new branch name, right, equals utils dot ask user for branch name. Cool. So now we have the branch name, and then we probably would need to have a repository. So something like ask user for repo link. If we assume that the repository is now some kind of object that we can use, then we could do something like repo.change main branch name, and then we give it the new branch name. Right. So this pretty much describes everything that we want to do. And it's just, well, basically 3 lines of code. So this amount of code is really easy to reason about, right? We have a couple of functions with pretty clear names. Of course, naming can be also always better, but I suppose this gets the point through. However, this is not everything that the project does, because what the project actually does, the Master Blaster project, is that it lists all the repositories from GitHub that you have. And then you can select from those projects, and then it will blast the master branches of those projects. So let's implement that in our utility pseudo language, shall we? So now instead of asking for repository from the user, we probably want to have some kind of repository for our repositories, which is now GitHub. So, well, let's just use GitHub, shall we? So we probably want to have something like GitHub client equals github.login. Let's not worry about how that GitHub login works yet, but let's assume that we have some kind of API client for the GitHub. So now that the user has logged in, we can list all the repositories of the person. All repos equals GitHub client dot list all repos. Cool. We're still under 10 lines of code, so looking good. And then let's jump back to the utils again. Let's ask for the user that which ones of these repositories would they like to blast. Okay, let's do just that. So we want to have selected repositories, and then we have something like utils dot select repos, and then we'll pass in all of the repositories. Cool. We're still under 10 lines of code. And to make it official, then we just need one for loop, right? So for repo in selected repos and something like that. Okay, so it still should be valid Python. Of course, it doesn't work if we try to run it. It throws some kind of errors, but it's looking quite good because this should be the, yeah. I ran it. It crashed because the object doesn't have the as for branch name, so which is the first from the utils, just as we expected. But still, this amount of code is something that we can reason about. This reads quite well. And if this would be kind of the main file of the project, I would be delighted. One thing I almost forgot is that the Master Blaster current project, it handles both your local Git repositories and your GitHub's remote repositories. So then we can't just assume that we have the GitHub here. So let's do some kind of abstraction for this. I would think that instead of like having one code that goes first through your local repositories and then goes through your online repositories in GitHub, for example, they are just repositories, but they are located in different places. So I would think that the abstraction there that abstracts repository sources, like whether it is GitHub or your local file system, or if it's, for example, Bitbucket or GitLab or whatever. So instead of using something like GitHub, I would probably use something like, let's ask the user for the source, right? So repository source is utils.asUser for repo source. And let's use just repo for short. Yeah, so then we can diss the GitHub, and then we can do the login towards the repo source, and then this would be something like repo client, right? Now you're still with me. So let's go through this line by line. We first ask for the branch name, right? Then we ask for the repository source, so whether you want to blast your local branches or the GitHub branches to begin with, for example. Then we use some kind of login or configure, for example, because if you have local repositories, then you probably want to just select the folder which contains all of your local repositories. And if it's the remote one, which would be GitHub, then you probably want to log in and do stuff like that. So we use something that describes both of them, which would be something like configure. That returns a repository client for us. Then we list all the repositories. So this would be kind of an abstract client, which can be either your local client or the remote one. It lists all the repositories, and then we ask the user to select the wanted repositories. We could probably optimize it by passing in the branch name to like remove the repositories that already have that named branch. But anyways, that could be done later on. And then from the select repositories, we just loop that through and then do the, so we don't even need this one anymore. So we're back to under 10 lines of code to describe the whole functionality of our system, and this is basically the beef of our system. So everything that we do boils down to this line of code, right? So we change the branch's name. That's the most important thing in here. Utils, of course, this is rather like bad naming. Don't ever use just this thing called utils. This would be user input or something like that. So because all of these functions are asking for user input, right? So now we would have one module that handles the user input. We could mock the user's input and then find out ways to answer these questions, for example, in a predictable way. I think the thing that was used here, it was called something like what was it? Questionnaire. Yeah, so I think this project had pretty well-defined tests too. So where can I go to? GitHub and tests, and then test prompt or something like that. Questionnaire prompt. So yeah, so I think this repository pretty well has means of testing the user's input and then kind of checking what it does with the input by giving the input using a test. You don't need to manually type in the input in these tests. So you want to test this kind of user input, you can check how this repository does it. Another thing here is that we have the abstract repository source, and this repository source is again something that you can write tests against. You can probably test all of this with mocked or faked repository sources and faked user input just to make sure that it works the way you are supposed to. Since you have under 10 lines of code, it's pretty easy to, even as a human being, to assess that this is working as it should be, right? We get kind of the good features of object-oriented programming by using this kind of approach to our coding, because then we can start mocking or faking these objects that we have here, and then bit by bit work our way towards a working complete system. But if you have functions or procedures, so to speak, that are only 10 lines long, then it's much easier to reason about them and to assess that these things do what we intend them to do. A quick end note, git commit history, just to point it out. Oh no, this describes the git history commit messages pretty well. You can check the previous YouTube video for how to write a good git commit message. But just to point out, this kind of git commit message points out that you're probably just hacking things together and not worrying so much about any kind of readability or maintainability, because this kind of looks as messy as the code that's in the bin folder. But all in all, I think the cause and the idea behind this project is really good, and you should definitely check it out. But this is all I have for you today. If you have any comments, and especially if you disagree with me, please leave a comment below, because I love to be wrong and I love to learn new things. If you like this video, please subscribe, and have a nice day and happy coding.